All right, it's me again. I'm sure you missed me. We're going to look at a little closer 3 examples of an integral as a net change. So I'm going to have you read the first problem and tell me what information you need, because you don't have enough to answer the question I've asked, and clearly I've left a big old blank spot there to write something in. So what is it you need to know to answer this question? Okay, so hopefully you said that you would need to know how far they had traveled from 5 to 7, right? Otherwise, we really can't do this one. So I'm going to put the missing information in here and say that by 7 a.m., the train had traveled 300 miles that morning. Okay, so then from 7 to 9, the train traveled at a velocity of 75 miles an hour. So what is the total distance the train traveled on that time interval from 5 a.m. to 9 a.m.? Go ahead and get an answer for that. Okay, so hopefully you said that 300 miles is kind of what we got at 7 o'clock, right? That's kind of where you started there. I'm going to start using some notation you're going to hear. And then you can figure that on 75 miles an hour, because we've done this problem 47 times, 75 miles an hour for 2 hours, that would be 150. You could have used an area model for that. You could have used common sense. You could have used just short-term memory, right? Because we've done this a few times. And then so by 9, you'd end up with 450 miles. Okay, just a little arithmetic. And so I'm going to kind of look at this as a where you start. This gets you lots of points on the AP exam. Usually they take this technique, this integral as net change, pretty seriously. So where you start, or you might even see it labeled as a function value at 7 a.m. or whatever they might use, but you'll be given a certain value, a starting value, and that's where you were held up because I didn't give it to you, right? You had to tell me to give that to you. And then you're going to do plus your net change. And remember, that's always an integral. And we've written this one as an integral. We're going to integrate our little velocity function here. I'll just say f of x. Going to integrate our velocity function. I should say 75 dx maybe, from 7 to 9. And maybe I will do that. And then what we're going to end up with, oh no, I can't be out of white. It'd be devastating. All right, we'll do 75. And what we end up with then when we add those together is how far the train had gone by 9 a.m. And I'm just using f at 7 and f at 9 there. Okay, so where you start, we knew 300 miles had been gone. We added the net change by integrating the velocity, and we can see the total distance traveled. Okay, so let's try another one. Let's look here. We got Miley, and she's read 215 pages in her choice novel. She reads at a rate of 2 pages per minute for 10 minutes. I say she then reads at a rate of 2 pages per minute for 10 minutes. So how many total pages has she read? Well, the idea is we know that before she started reading at this massive rate of 2 pages per minute, she'd already read 215 pages. So where you start, 250 pages, 215 pages, that's your start, plus your net change. So 2 pages per minute for 10 minutes. We're just going to integrate that little pages per minute. I'll just say from 0 to 10 minutes, and then we'll get where we end up. So where you start plus the net change, which is always an integral, is where you end up. End pages or total pages, however we want. Total is probably a better way to say this, right? Okay, so let's look at this. 215 plus, for 10 minutes, 2 pages per minute, 20 pages total, equals 285 and 35 pages total. Where you start plus your net change. So if you've got a rate, you can integrate it. If you integrate pages per minute, you get total pages. If you integrate miles per hour, you get total miles traveled, right? So we can use that integral as net change idea. Okay, last one. We got Trevor. Trevor eats 14 donuts for breakfast. For a mid-morning snack, he begins eating at a rate of 3 donuts per second for the next 5 seconds. So how many donuts has he eaten in all? So pause me and give this one a shot. Okay, at the start, Trevor had already eaten 14 donuts. And then he starts eating them tragically fast at a rate of 3 donuts per second. I'm spelling donuts the short way. I know it's not really quite correct. For 5 seconds, which I guess would result in 15 donuts, right? And that'll be his total. So where you start plus your net change is where you end up. In this case, integrate donuts per second. We get total donuts eaten in there. Add to what he started with, and we'll get the absolute total donuts he's eaten that day. So let's go ahead and do this. 14 plus, if you integrate 3, we'll get 15, or just common sense is fine. And then we'll get a total of 29 donuts eaten for that day. Okay. Okay, that's it for me. I'm going to come back and talk about just a couple more things in the next videos, and then we shall finish for the week. All right, folks.